All right, morning everybody. So this was our second mock exam. Pass mark is only 35%. So no doubt everybody would have attained that. It's progress before perfection. So they know those pass marks. They will climb as time goes by, right? So make sure you're climbing along. The key thing is to learn from the mistakes and not repeat the mistakes when we do the subsequent exam papers. Right? And look here. There's no reason for anybody to be saying that they didn't know that we had a mock exam. We have a mock exam every single Saturday, unless me say otherwise. Every single Saturday we have a mock exam. And we're also going to be doing mock exams in the week. We have a couple of topics left to go through, to go over in the week. In fact, I think this is the last week I'll be doing anything. From next week, for sure, you'll be doing mock exam on Saturday. I also be doing mock exams in the week, Wednesdays and Thursdays. The more we do, the better. Have to get comfortable with these things, with these exam papers. And as I said, key thing is to do the questions. I'm going to work through the question now. You made a mistake on something, you're going to redo it. Do it over. I have to lock in on those mistakes. You're more interested in what you got wrong, not what you got right. You're interested in what you got right. You cement it and you give confidence that, yes, I did the right thing. But particularly, you're interested in what you got wrong. Those are the things that you want to zoom in and focus on, do over the question, know the mistake that you made, how you made the mistake, and ensure that you don't make them again. So you get questions like them again, you make sure you don't make them again. The more questions, the more papers we do, the more you get familiar with the exam questions, the more you get familiar with doing and getting them right. The more you learn from mistakes, the more you understand what you're actually doing. Right? A lot of things become clear, you put pen to paper. It's very important that you come here and do the exam papers here under exam conditions. I could have chosen the easy route and just send the papers for you to do at home. But I care so much that you actually do the paper that I come here on a Saturday and sit down and watch you do the papers. You also have to learn how to manage the time in the exam. You have to know what the time feels like. You have to learn what 10 minutes feels like. You have to be working and know, so okay, 10 minutes pass in your head. You have to have that internal clock. And so you have to practice it. You have to know that from the get-go, you have to start working quickly. There's no warming up time on the exam paper. There's no time to warm up. As the exam paper starts, you get going. Because the time starts as soon as the exam starts. You know, giving a break time and say, okay, warm up a little bit and then you start. No. As soon as them start working, the time starts to decrease. You see that? Before you know it, the first 10 minutes pass. It feels as if as we start the exam, the first 10 minutes pass. Youngsters, pay attention, man, and that's with the phone. Yeah, we start class now, you can't do SBA now while I'm doing the class. You're doing SBA outside of class. Sure, never get 100% on this paper. There are things to learn on it. Pay attention. There's a time for everything. A time for the SBA, a time for class. Now you want to go through this paper, see what mistakes you made, get the understanding of what you did not understand, make notes, redo questions, make sure you don't make the same mistakes again. That's what it's all about, eliminating mistakes. You don't want to take the mistakes in the exam room. The more questions you can learn how to do the right way, is the more you get correct in the exam. And the greater your grade will be. That's what the exercise, this process is all about. Doing as much work as possible, making as many mistakes as possible before the exam. You don't want to carry those mistakes into the exam room. Make the mistakes now and learn from them. All right, cool. All right, so doing this paper again, I think I'm going to do it from number 11, from number 10, work our way to the front. I pretend to focus more at the beginning. But I feel like I get a little bit better and so on. We start at the front. All right? So I'm starting at the back as usual. So starting on the last question, which is number 10, right here. Vectors and matrices. Sometimes the vectors question comes first, sometimes the matrices question comes first. I will give 20 minutes for this question. 10 minutes for the part A, which is vectors, and 10 minutes for the part B, which is matrices, transformation. That's what the 10 minutes is about. So even when you're timing yourself on the section 2 question, it's 10 minutes each part, because each part is a different topic. All right? All right, so part A is your vectors. This is it. It says, points OP and R are shown on the grid below. O, P, R, 3 points. O is the origin. It says, write the position vector of R, OR, in this form, in column vector format. Coordinates of R right here are 5, 1. So the coordinates will have the same values. So OR will have the same values, 5, 1, in a column vector form. No calculation needed for that. P over here is the point negative 2, 4. And we're going to need it. And so OP would be negative 2, 4. We're going to need it. We're going to need it in the question, if they don't ask for it right here. So those are the 2 portion vectors for those points. So this will be the vector OR right here, this straight line vector, OR. And this will be the vector OP right there. That will be the vector OP. All right? Next part says, another point Q is located such that QR is equal to 2, negative 4. And I want us to use this information to plot the point Q on the graph. Where's the point Q? Now, what does this mean? This means to go from Q to R, you go 2 to the right and 4 down. That's what that means, you know. What does the point Q? So we can reverse this and say, okay, if this is to go from Q to R, they can reverse that and say, okay, it's going from R to Q then. So we can start from R and locate Q. Going from R to Q would be the negative of this. RQ would be the opposite direction. And opposite direction in vectors, you introduce a negative. So if QR is 2, negative 4, then RQ is negative 2, 4. This means to go from R to Q, we will go 2 to the left and 4 up. That's what that means. This is like a translation vector, just to say it. So we can start at the point R and reach Q by going 2 to the left and 4 up. We can do it graphically, like that, right? So this means 2 to the left, this way, starting at R, we got 2 to the left, this way, and 4 up. And we will reach the point Q. They want us to plot the point Q on the graph. So if I go on the graph, I got 2 to the left, 4 up. I'm going to show you 2 ways to do it. Starting at Q, to locate R, we can go 2 units to the left. And check the grid. This is 1 unit horizontally, and this is 1 unit vertically. So you make sure that you check the scale of the graph. See the values here? 4 to 5 is 1 unit that. And vertically, 1 to 2 is 1 unit that. So horizontally is 1 grid is a unit. Vertically, 1 grid is a unit. So 2 to the left. So 2 to the left here, so. And then 4 up. 1, 2, 3, 4. That's 2 to the left. That's a -2. That's 4 up. So it means that Q is right here. Q is right here. That's where Q is. I can look at the graph and see that Q is a point 3, 5. 3, 5. So Q is a point 3, 5 on the graph. So if Q is a point 3, 5, then you also know that the vector OQ, that's the vector from O to Q right here. That vector OQ would have the same value as the coordinates 3, 5. That's doing it graphically. Understanding that the vector, this vector, is how you go from Q to R. You can check if this is correct. Because this would say now going from Q to R, you got 2 to the right and 4 down. See it here? going from Q to R, that means a different color. It will be 2 to the right, if we're going from Q to R, and 4 down. See there? 4 down. That's minus 4 and the 2. Going the opposite way. All right? Going from Q to R. That's what the vector means. But we could have done this by calculation as well. That's doing a graphical method. But all the question I want to do is to plot it, you know, as 1 point for it. You know. So we could plot it using this vector. But let's say I wanted to get the coordinates of the point Q. I get the portion vector of Q, OQ. You could start with this vector and split it up. Look, this is method 2, or a calculation method. We get the OQ. Because we get OQ, they know the coordinates of Q. Because the position vector of Q and the coordinates of Q are the same value. So if you can find the portion vector of Q, which is OQ, they know the coordinates will have the same values, and they can plot the point. So we're using a calculation method now, starting with this vector that they tell us is QR. So they give us QR is equal to 2, negative 4. And out of this QR, I know the OR. What I'm trying to find is the OQ. So what do? You split this into position vectors. Split it up into position vectors. I taught you that already in the class. When you have a displacement vector equation, you want to split it up into position vector. You split it using O times the last minus O times the first. I'm going to split this QR, split it into position vectors. This becomes OR minus OQ. OR, which is O times the last, minus OQ. OQ. O times the first. That's what this side becomes. OR minus OQ. And it is equal to 2, negative 4, same way. OQ, you want to make the subject. So we can take this negative OQ, bring it over here, make it positive. And take this 2, negative 4, bring it over here and subtract it. We will continue up yesterday. So when I take this OQ over this side, it's going to become a positive OQ over there. Equal, the OR is still there. And then this 2, negative 4 comes over and becomes a negative minus 2, negative 4. And what is the OR? Let's put in the values now. The OR, remember, is 5,1. So this OR is 5,1. So this then becomes 5,1 minus 2, negative 4. That's what OQ is equal to. Complete this calculation. 5 minus 2 is 3. 1 minus a plus. 1 plus 4 is 5. That is what the OQ vector is equal to. So OQ is equal to 3, 5. So if OQ is equal to 3, 5, it therefore means that Q has the same values, 3, 5. So you could have done it that way and plot that point on the graph. See there? Q is a point 3, 5. But in this example, the graphical method is easier. Okay, just count the movement from R to Q to find Q, as I did in the first part. 1 mark for that. You don't want to know how this works for 1 mark, guys. Right? But understand that. But go on. So go and do it over, get it right. You never get it right. It's not complicated, it's not difficult. All right, that's first part. Next part now says, we must find the modulus of QR. Modulus is the length or magnitude. This word, it means modulus. They could have said modulus or length. This is referring to the length of the line QR. That's what they want. Length of QR. This is the length of QR. That's what this one. And then another word for length is modulus. So you could have given that as well, modulus. Again, you can do it graphically. But since we know that the vector QR is this vector, this is vector QR, 2, negative 4. Then the modulus of QR is the square root of 2 squared and the 4 squared. Because the Pythagoras' theorem, it comes from. Let's look at the graph. So QR is this line. I'm just explaining it now. QR is this line. I want to know how long that line is. This side is 2 units here. That's what the 2 stand for. And right here, so it's 4. 4 down. That's a right angle triangle we have. Pythagoras' theorem says that this side length is the square root of this side squared, which is 2 squared, plus this side squared, which is 4 squared. That's how we get it from. Root of 2 squared plus 4 squared. That's the explanation behind it. We cannot use the values and the vector as we did here. The 2 and negative 4. And we do have to square, we do have to put negative 4 here and square it. But negative 4 squared and positive 4 squared is the same. The negative in that negative 4 is just a direction, meaning down. But the length of the line is still 4. Understand? So that's why this is just the square root of 2 squared plus 4 squared. And you can leave it in this format. This is 4 plus 16. That's 20. So you can leave it at the square root of 20. It is okay to leave it like this. Square root of 20 units. That's the exact value of it. And the character might simplify it for you. I'll give you 2 root 5. 2 times the square root of 5. They could give you that. Because this is the same as the square root of 4 times 5. The 20 is 4 times 5. The square root of the 4 is 2. And then you have the square root of 5. Let me put this part in a different color. Put this part in a different color. What it could have been. So it could have also been that the 20 is 4 times 5. And the square root of the 4 part is 2. And you're left with the square root of the 5. So you could have also given this as the answer. The calculator would give you this. 2 times the square root of 5. But the calculator is going to give you the lowest terms. But I think if you left this as the answer, they give you the marks still. But good. This part says show by calculation that OPQR is a parallelogram. I like to ask this in CSEC. Parallelograms in vectors. And to show a parallelogram, all you have to do is show that the opposite sides are equal vectors. That's what they need to show. To show that a parallelogram should use a vectors method to prove that a shape is a parallelogram. You have to show that the opposite sides are equal vectors because a parallelogram has 2 pairs of equal opposite parallel sides. When 2 vectors are equal and parallel, or when 2 lines are equal and parallel, when you have parallel vectors, equal vectors, the vectors are equal. When 2 lines are equal and parallel, they produce equal vectors. So because the opposite sides are equal in length and parallel, they are equal vectors. So you need to identify the opposite sides and show that the vectors are equal. The opposite sides are equal vectors. So I will come back on the diagram up here. And we're talking about this parallelogram now. OPQR, them say, right? So O to P and R to Q are equal vectors. And O to R and P to Q would be equal vectors. So this vector is RQ, and this vector is OP. You have to show that they're equal. Right? So let me write it over here. Need to show. What we need to show? Need to show. In order to prove the parallelogram, we need to show this. We need to show that RQ is equal to OP. RQ is equal to OP. Let's show that. And the opposite side, these 2 sides are also equal, which is PQ. PQ is equal to OR. Is equal to OR. Those are the opposite sides. We also need to show that PQ is equal to what OR is. That's what we need to show through the parallelogram. But work this out and show that this is true. Show that all of this is true. with numbers. That's a show by calculation. See? Show by calculation. So don't know what you have on the diagram. Show by calculation. So I have to prove this thing that I've drawn in red. So you tell the examiner that's what you need to show and then you show it. You cut this, piece it down here. Paste. Paste. That's what I need to show. Alright? Then let's do it now. We know the OP already. What was the OP? Let's see what the OP was. The OP was already negative 2,4, right? So I already know that the OP was negative 2,4. The OP was negative 2,4. And the OR was what again? The OR was 5,1, right? The OR was 5,1. Yes, OR was 5,1. All right. So we know this is negative 2,4, and we know this is 5,1. So we need to work out the RQ and the PQ. Let's work out the RQ. I think we have the RQ already from up here now. We have QR. So therefore the RQ, I think we wrote it down here. RQ. So we have that already. See? So we have that already. So we already have that RQ is equal to minus 2,4, which is the same as OP. So I've proven this part already. This part now, PQ we don't have it. So PQ, so we can say now PQ, we don't have it when I work it out. It's out on the last one, it's out on the first. It is OQ minus OP. The OQ is what we just work out, the 3,5. Remember? The OQ is 3,5. Where is it? 3,5. So the OQ, remember, is 3,5. Minus the OP is still negative 2,4. And then you work this out. This minus becomes a plus. That becomes a 5. And then 5 minus 4 is 1. See that? So the PQ is equal to 5,1. And the 5,1 is OR. That's equal to OR. So this thing is also shown. So I've shown it by calculation. See that? So tell the examiner that's what we need to show anyway. Write up on the paper and then you go about showing it. Alright? So look here, guys. Next time when I get a question that says show that something is a parallelogram. I don't want anybody one of them can beat. Because we done this at least 4 times already. Because the CSEC like to ask this. It don't make no sense CSEC ask something multiple times in the past. And then when you ask them, your exam can beat. That don't make no sense. Anything that CSEC asks repeatedly, you must can do it. And they like to ask the proof for parallelograms. And this is what you do. Identify the opposite sides, work out the vector them and show that the vector them equal. That's all. Right? That's all. And so therefore, we have shown that OPQR is a parallelogram. You have shown because you prove these things to be true. The opposite sides are equal vectors. That's it. But God, never get it, you do it over. Go and do it. Go and do it. Next question. The matrices. Start out with the matrices. It says, calculate the value of the x and the y. So the x here, and so the y here. What this is a multiple of 2 vectors. This times this equals that. So this is what we call an equality of matrices question. You have to know, for example, that this x is a product of this row and this column. Right? That's where you start. You set out the equation and calculate x. And you have to also know that this row times this column is equal to the 6. And set that out again and you work it. You understand? That's how you solve this question. Equality of matrices. Alright? So you go ahead and you do it. So let's do it. When I write out that this row times this column is equal to the x. So the 1, 5 row times the minus 4, 2 column is equal to the x. And go about and work it out. We work this out. 1 times negative 4 and 5 times 2. First element times first element, second element times second element. So the 1 times negative 4 and the 5 times 2 is equal to the x. 1 times negative 4 plus 5 times 2 is 10. That's equal to the x. That works out to 6. 10 minus 4 is 6. This is 6. So you can say therefore the x is 6. So this works out to be 6. But good. Then the other part, it is this row times this column that is equal to this 6. Because we have to use a multiple that involves this row now. Remember, you're only using the rows from the first matrix in the calculation. When multiplying matrices, you use the rows of the first matrix and the columns of the second matrix. So the calculation they're going to do must include a calculation with that row now. If you want, you could use that row and this column equal to 65. But why go to 65? Better we use this row and this column. So let's set up again. So the 6 down here is the product of this row and this column. So you can set out the row 2y times the column negative 4, 2 is equal to 6. And so you set up equality of matrices. And let's expand it out. 2 times minus 4 and the y times 2 is equal to 6. So it's 2 times minus 4, 2 times minus 4 plus y times 2, y times 2. That's equal to 6. The 2 times minus 4 is negative 8 plus the y times 2 is 2y. That's equal to 6. Take the minus 8 and carry it away and add it. You get 2y equals 6 plus 8, which is 14. 2y equals 14. Divide both sides by 2, you get y equals 7. So the y equals 7 if you divide both sides by 2. Nice and easy. That is it. X equals 6, y equals 7. But all right? Simple as that. Equality of matrices. Let's go. Next question. Next part says transformation is represented by this. You must know that matrix as you look at it. That's a y equals x reflection matrix. I just see the matrix, you must know. That's all we want to know these things. So all this information after this now becomes irrelevant. Irrelevant. You just know the matrix on site. That's how you prepare for exam. Know what you need to know. 0, 1, 1, 0 is a y equals x reflection matrix. All right? So other people now have to use these 2 points and put it on graph and look at it and all those things. Waste of time. You cannot be penalized for advanced knowledge. You cannot be penalized for knowing that that matrix is a y equals x reflection matrix and write it down. This becomes irrelevant. You don't need that. And it is true because the y equals x reflection matrix reverses the coordinates. See? 2, 5 becomes 5, 2. That's what the matrix does when you reflect the line y equals x. Coordinates are reversed. More things you know, the better. Right? So that's a reflection in line y equals x. It's 2 free marks that you know. If you get the exam, you're supposed to be happy. That's like 2 free marks I just gave you right there. All right? So let's go. So T is a reflection in the line y equals x. That's it. Done. When you're describing a reflection, just state the equation of the mirror line. I'll state the mirror line. A reflection in the line y equals x. Done. Very good? All right, let's go. That was number 10. Let's go down to number 9, which is our trigonometry question. Right? Geometry and trigonometry. All right, here first we have a circle theory. Diagram below shows a circle with points P, Q, R, and S line on a circumference. And the center is O. RP is a diameter, so you're supposed to think about diameter rule. Diameter sub 10, 90 degrees at the circumference, right? And ABC, that AB is a tangent. So what's between that tangent and radius is 90 degrees, tangent and chord. Angle between a tangent and a chord equals the angle subtended by the chord. Know the rules, the question get easy. It says angle APQ is 3x. That's right here. That's angle between the tangent and the chord right now. That's angle between the tangent and the chord. Right? And angle QPR is 2x. That's right here. It's 2x. And angle RPS is x. That's right here. X. And angle QSP is 54. Right here. It's 54. But the thing about this question, there's always, a lot of the time, multiple ways to answer the questions. All right? So just which method you use it first. Which rule you say you can apply first. You apply it. Our question says, determine each of the following. Determine the value of each of the following angles. Show detailed working where necessary and give a reason for your answer. First I want is x. I want angle x. All right? Now, you can use any part of information you want to find angle x, right? All right. So, suppose you're focusing on this x right here. You might say, okay, what is that x? Okay, I'll find that x. But what I would know to begin with is that you have multiple ways you can do it. I would know that this tangent and this radius are 90 degrees between them. So the 5x side equal 90. So that 2x and the 3x is 5x equal 90. And between a tangent and a radius is 90 degrees. That's one way. Another way you could find the x is to go tangent and chord, which is this angle right here. Angle between a tangent and a chord is 3x. Angle between a tangent and a chord is equal to the angle subtended by the chord at circumference up here, which is 54. So the 54 there is equal to that 3x there. So angle between a tangent and a chord equals angle subtended by the chord. So you could also say 3x equals 54. And get the answer safely. Your choice, whichever one you want to use. Right? Is there another way to find x? Right now. Is there another way you could find x? All right, that's the two ways I'm seeing, right? All right, that's the two ways I'm seeing off the bat. How can I use to find x? So, whichever method they want to use. Let's use the tangent and radius. Tangent and radius is 90 degrees. So I want to find this x, right? I want to write that 2x plus 3x equals 90 degrees. Equals 9. I'm leaving out the degree. Because the question gave you x degrees, so the x are those values, right? X are those values. So I don't need to put a degree on this. Because these are angles are in degrees. So I can leave off those degrees if I'm just finding the value of x. But understand that 2x plus 3x is 90 degrees. Reason? Angle between tangent and radius is 90 degrees. That's 5x equals 90. So x equals 90 over 5. What is that? What is that? 90 over 5. What's it again? 18? 18? 18. X equals 18. Reason we're using is angle between tangent and radius is 90 degrees. That's what we use. angle between a tangent and a radius is 90 degrees. That's it. All right, so the angle X is 80. What do I want next? I want Y. Angle Y. Let's look at it now. So X is 80. So now I want angle Y right here. Now, that angle Y, you can't see what it is right off the bat. What you can do is find what is subtending the angle. Now watch this now. These two angles are up to 90 degrees. The X there and the Y they equal 90 degrees. Why is that? Because this is the diameter. A diameter will always subtend 90 degrees at the circumference right here. So this angle is 90 degrees. But understand that? Good. So in this triangle, if this angle is 90, these two are what we call complementary angles. They add up to 90 degrees. So the Y is 90 minus the X, or the X plus Y is 90. But understand that. So the Y becomes 90 minus X. So I will tell him that this angle is 90 degrees first. All right, so I want to tell him that this angle RSP is 90 degrees first, because it's subtended by a diameter. All right, so let's do that. So first we're going to tell them, we can tell them the answer right after. The Y is equal to 90 minus X, which is 90 minus 80. And what is that? Minus 10 first, we get 80, minus 8 more, we get 72. 82. What are we going to do that? What's the reason now? You're going to first tell them that the angle is 90 degrees. This angle down here, so. RSP is 90 degrees. That's something by a diameter. So angle RSP equal 90 degrees. Why? Subtended by diameter. Angle subtended by a diameter is 90 degrees. And after that, now the total angle in the triangle is 90 degrees, right? Total angle in the triangle, this triangle we're talking about. Triangle RSP. Total angle in triangle RSP is 180 degrees. Therefore, angle X plus Y is 90. That is why we use this. Y equals 90 minus X, because X plus Y is 90. They are complementary angles. That is it. Then I want angle Z next. Angle Z. Angle Z and angle Y equal. Why is that? Because angle Z is subtended, if we come back to the reach circumference, is subtended by this chord. And the same chord is subtending this angle up here at the circumference. So these two angles are subtended by the same chord. Same chord SP. I can say they are subtended by this arc around here. Angles in the same segment are equal. So Q and Y equal. What good? Q and Z, sorry, not Q. Z and Y equal. Z and Y. So Z and Y equal. So angle Z is equal to angle Y, which is 72. Because angles in the same segment are equal. Right? Angles in the same segment are equal. If you want to add more to it, and say when subtended by the same chord or same arc, they are equal. That's what we used. Both of them subtended by the same chord. Don't you see? This angle and this angle, they are both subtended by this chord. If you like, you would say there's something by this arc, this red arc, something in those two angles at the circumference, and they're both in the same set. That's why they are equal. That is that. Nice and easy. Then we'll come to this one down, which is our bearings. Question says, diagram below shows straight roads connecting towns L, M, N, and R. It says LR is 18, that's here. It says LN is 12, that's here. It says MN is 10 right here. It says angle RLN is 25 degrees inside here. And it says angle LMN is 88 right here, 88. And they give us this angle. That's a bearing angle, see? Clockwise from the north line. That is a bearing of this direction from L to N. L to N is 50 degrees. That's a bearing, 0, 50 degrees. Calculate angle MLN. Where's that angle now? MLN. That's this angle inside here. Let's call it alpha so we can reference it. Let's call it angle alpha. Right here is alpha. So we want that angle. So we're going to be working in this triangle. But that triangle is not a right angle triangle. So we can't use Pythagoras theorem in it. We can't use SOHCAHTOA tower in it. We have to use either the sine rule or the cosine rule. Look if you can use the sine rule first. Use the sine rule, remember you need an angle and a side opposite each other where you know both of them. We have it here. See, these two, they are opposite each other. And we know both of them. We know the angle and the sine. So we can use the sine rule. So in the sine rule, we're going to be using this pair with that pair to find the angle alpha. But I said that. Sine rule. Start with what you want. So we're going to use sine rule. For alpha in triangle MLN. Start with what you want. Sine of alpha over the side opposite the alpha is 10. Equals sine of the angle that you know. The angle that you know is 88 degrees. Over the side opposite 88 degrees is 12. But understand that. You're transposing this to make alpha the subject. How we do it? Multiply up the 10 up here so first. Let me show you step by step. You will get sine of alpha equals 10 times the sine of 88 degrees over 12. If you take the 10 and multiply it up here, so first, that's what you get. What is alpha we want? We want to take the inverse sine over this side. So I'm actually going to move it for you so you can see it. Put the inverse sine over here, sine to the minus 1 of that. And then do the calculation one time. What I say that? And you do the calculation with the calculator now, and we'll get the answer. See it here. So it becomes sine to the minus 1 of a fraction, and it's 10 times the sine of 88 over 12. See there? 10 times the sine of 88 over 12. And the answer there is 56.4. That's 56.4 degrees. 56.4 degrees is the answer. Corrected to 3 significant figures, 1 decimal place. Then calculate the distance NR next now. Let's go on to how we're gonna get NR. So we'll about this part. Let's put it on there, 56.4. Let's put it in there. This angle is 56.4. That we just worked out. 56.4. Let's put it here, so 56.4 degrees. Now I want us to calculate NR, this side. To calculate NR, now we're gonna work in this triangle. However, in the triangle, we have two sides and the angle between them. It's a typical case now for the cosine rule to calculate NR. So cosine rule for NR now. We're going to use cosine rule. What are the sides again? Let me write on the sides. So we're using the sides 12, 18, and 25 degrees in the cosine rule, right? Those are the dimensions. Sides are 12, 18, and angle is 25 degrees. Put them in the cosine rule. So the NR squared equals, remember it starts like 5,000 stereo. 12 squared plus 18 squared. Well, it's not 5,000, so you have to subtract a piece. So you subtract 2 times the 12 times the 18 and times the cosine of the angle between them, which is 25 degrees. Instead of squaring here, we can square both sides. Cut this square and square root all of that side, and then put that in the calculator to get the NR. So NR becomes equal to, let's put this in the calculator now. So it becomes the square root of 12 squared plus 18 squared minus 2 times 12 times 18 times the cosine of 25 degrees. It comes out to be 8.75. I'm going to use 3 significant figures. 8.75 kilometers. 8.75 kilometers. That's 8.75 kilometers. That's the answer there. What I got? But all right. It's the same thing asking all the time in these questions. You have no business not getting these things right. Same thing they're asking all the time. Next question says, determine the bearing of R from L. Remember, when you're doing bearing, you want to know the from position. So it's from L to R. You want the bearing in the direction L to R. That's what you want. The bearing of the direction L to R. Remember, bearing is a direction given at an angle clockwise from the north line at the from position. All right? So, bearing from L to R. Yes, you got it. So, see L here, so, and see R here, so. So, you want the bearing down to this direction. You want the bearing down to that direction. All right? So, that bearing angle is this angle that I'm going to mark in red and purple. So, see the from position here. This is the north line. The bearing of this direction down here is a clockwise angle all the way around to here, so. That's the bearing angle. But I agree with that. That's the bearing angle that I want. And that bearing angle is just some of these three angles, 50, 56, and the 25. But I can agree with that. That's the bearing angle that I want, right? Let's call it theta on this diagram. So let me draw this over. Let's call it angle theta. So that bearing angle that I want, theta, is 50 degrees plus 56.4 degrees plus 25 degrees. That is the bearing angle that I want. I'm going to tell the exam. I'm leaving that drawing on the diagram now. I'm leaving it on the diagram. So the examiner can see. The diagram is a part of the solution. So bearing of L from R, I'm going to tell the examiner, is theta on my diagram. I'm going to tell him what theta is now. Theta is that. So that works out to be works out to be 50 plus 56.4 plus 25. 131.4. 131.4 degrees. But bearings usually given us 3 digits. Let's put 131. Run off the nearest 3 digits and put that as the answer right here. Put this as the answer. 3 digits. The bearings are always given to 3 digits. They correct it to 3 digits. You just, you don't usually put decimal point on bearings. Alright? Leave it with the 3 digits. That's it. But alright. Alright, that just stand down. Let's go down to number 9. Number 9 right here. Oh, number 8, sorry, number 8. Just did number 9. Number 9 says, they give us this function f of x. This is it, f of x. I just see this negative x squared, you know, is a front graph, right? And a front graph has a maximum point, a maximum turning point. You're supposed to know that. And it's a quadratic. Quadratic function has a line of symmetry, an axis of symmetry. And it's always such that the y values are symmetrical about one of the lines up here representing the line of symmetry. It's not going to be here. It's actually going to be between these two right here. That's going to represent the line of symmetry. Is that line right here. See it? Right between the 9 and the 9. So the line of symmetry would be represented basically in between these two values. That's represents the symmetry of the graph. So the values are symmetrical this way and that way. Same values outward from that line of symmetry, the y values. So that red line represents my axis of symmetry right now. So the x value on that axis of symmetry is between the 2 and the 3. Halfway between 2 and 3 is 2.5, 2.5. That's my xt value. So I know right away that the x value, my turning point, is halfway between these two. This red line will be halfway between 2 and 3. That's my xt value, my turning point. That's represents where my axis is, the turning point. xt, t means turning point, is the average of the 2 and the 3, which is 2.5. And then now to get the yt value right here, the y value at that point, the yt value, you can take this 2.5 xt value and put it in the function and work out what the y value is when you put the 2.5 in that. So you can have that information before you even start working. All right? So this will work out to put the 2.5 in this. It will be 3 plus, let me copy this though, make this further. White would be 3 plus 5 times 2.5 minus 2.5 squared. You work out that y value, that's a y value turning point. I'm just showing you one way to do it. You can use the formula that we normally use anyway. That's a YT formula if you want. But you remember, the quadratic graph has a turning point, so you don't ask for it, you still have to put it. Because to draw the graph, you make sure that it passes through that turning point and show that turning point. And they will more than likely ask you a question about it. I'm just working it out from now. All right? So this is 3 plus 5 times 2.5 plus, no, not plus, minus 2.5 squared. That's 9.25. 9.25. It means that my maximum point is this x value and this y value is 2.5, 9.25. They did not put that on the graph, but that's a point on the graph. They're not going to give you everything. They expect you to know that. That is a maximum turning point at 2.5, 9.25. xt means x value turning point. Yt means y value turning point. We calculate them the normal way. Minus mu by 2a and so on, you're going to get them just the same. Now watch this now. Remember that I said the values are symmetrical about this way and this way, right? So you see whatever value goes here, the same value goes there. You see this tree, the same value tree going right here, so because of the symmetrical nature of the values. You don't have to work out everything. I'm going to work them out and show you, but you can know without doing anything. So whatever value goes here, the same value goes there. So I can use the 1 first in the function and see what that is. So right here is where x equals 1. Let me put it here. Right here is where x equals 1. So x equals 1. So put it in the function, the y value. Further down, Mr. Shaw. So right here is where x equals 1 and y becomes equal. Put the 1 in this. Becomes 3 plus 5 times 1 minus 1 squared. That's 8 minus 1 is 7, right? But I give it that 7. So right here says 7. So I can tell that here says 7 as well. This is 7 and this is 7 as well. But the values are symmetrical. But if you don't make it work it out, by plugging the 4 in this function right here, same way. Put the 4 in this. It will be 3 plus 5 times 4 minus 4 squared. That will be, that's 3 and 20, that's 23 minus 16, 4 squared, 16. 24 minus 16 is 7 as well. It's 7. Why did that work that out? I'm going to show you. And then because this value is 3, that comes after the 7, and after the 7, this way is also 3. So right here is a 3. That don't need any work. So right here is a 3 as well. We could do 3 as well because we get the 0. Put the 0 here for this, it's gone. And put the 0 here, it's gone as well. So f of x equals 3 right there. When x is 0, the y value is 3. But it is 3 because also of the symmetric nature of the values. Alright? So basically that is that. So those are the values. And so you complete the table there. You can calculate it, but you can use symmetrical nature of the values just to see. Alright? Then I want you to draw the graph on the next page, right? On the grid, draw the graph. So they give us the points. They put on the points that they gave you in the table, but not the other ones. So we put in the maximum point, which is 2.5, 9.25. Let's put them on in red. Those additional points. Let's put on the maximum one first. The 2.5, I see, is right on this line, 2.5. That's the axis of symmetry, this line. And you need 9.25. So right here says 9. And right here says 9.5. Halfway between the 9 and the 10 is 9.5. Let me make the pen out of it now. So right here is 9.5. So 9.25 must be about halfway here, so. Right? This is 9.5 and right here, so. So 9.25 is about here. So this is 9.25 and this is 2.5. The maximum point is somewhere around here, so. That's the maximum point. That point on the graph right here. Let's put on the others. So the other points were 0, 3 and 1, 7. 0, 3, 1, 7. So 0, 3, 0, 3 is right here. 1, 7, 1, 7 is here. Then which other point we didn't have? Then 4, 7. Oh, we didn't put on this one out here, so no, this one. So what comes after the 3 is negative 3. So here must be negative 3 as well. I didn't put on this one in. So out here, there's an empty cell that we left out here. So you see, this is 9, 7, 3, negative 3. This one will be 9, 7, 3, negative 3 down here. So out here is going to be a negative 3 as well. Right here is negative 3. If you're not sure, you can work it out by taking the 6 and plug it in their function. Put the 6 in there if you want to work it out. All right? But I could know that that's negative 3. But if you like, you can put the 6 in there to get it, right? Right here, so. All right. Put the 6 in this, you get the -3. So -3 is 6. No, that's 6 -3. Sorry, 6 -3. So 6 -3. So it's in line with this one. So 6 -3 is right here. And we left off another point, which was 5, 3, 5, 3, and 4, 7. So 5, 3 is given, 5, 3 is given, 4, 7, 4 up to 7 right here. So here is 4, 7. So those are your points. And I want to draw the graph now. So draw the smooth curve through those points. And go on, let me see if this can draw it for me straight. Nope, not quite. Let's draw it over. All right, something like that. Give them something like that and they give you a mix, all right? Make sure you show that maximum point up here. All right, that's it. Next question says, write down the equation of axis of symmetry. Remember the axis of symmetry? This is vertical line through the turning point, right? This line is axis of symmetry. We draw it in purple. That's axis of symmetry. All right, that line is axis of symmetry. All right. All right, so the maximum y value, so this y value, highest y value on the graph here at its maximum point. All right, 9.25. Now this maximum point, its maximum point is 2.5, 9.25. So this is your maximum value. This is your maximum value. Highest y value on the graph, 9.25. So the maximum value is the YT value, which is 9.25. That is it. But okay with that? But good?
Yes, sir.
All right, good. This question says no. Write down coordinates of the point where this line crosses the x-axis. Now, on the x-axis, you know that on the x-axis, the y value is 0. On the x-axis, the y value is 0. So we're going to put the 0 here for the y. Right? So it means then that the 3 minus half x is equal to 0. For the y is 0. So this whole thing, which is the y, becomes equal to 0 on the x-axis. Alright, so we're solving this now for the x. Let's take the half x and bring it over here. You get half x equals 3. Let's take this one multiplied up here, so you get x equals 6. This tells us that the x is equal to 6. And what the coordinates? So the point is 6, 0 is the answer. This is the answer, right? 6, 0. X is 6 and y is 0. And then on the y-axis, you should know that x equals 0. That one easy. If this x is 0, put a 0 here, then the y is going to be equal to 3. Right? So at x equals 0, the y is going to be 3 minus half times 0, which is equal to 3. So that point is 0, 3. 0, 3 is the answer for this one. Zero, 3 is the answer for that one. All right? It says on the grid on page 22, draw this graph. So draw that graph and put on these 2 points, 6, 0 and 0, 3, and then draw the straight line to them. 6, 0 and 0, 3. 6, 0 and 0, 3. Let's use the reading for that. 6, 0 is right here. This is 6, 0. And 0, 3 is right here. This is 0, 3 right here. And there's a straight line to those 2 points. Right? So we're talking about this point is 0, 3, and this point is 6, 0. They put in a straight line to those points. All right? So it could be something like, let me draw it over. That will be the line. I can extend it back. And draw it forward. That's the line. This is the line. Y equals 3 minus half x. That line. This is the line y equals 3 minus half x. All right? What is it? And then the question says, use your graph to determine the solution for these 2 equations. At the point of intersection, this is the curve, and this is the line. So this represents the point of intersection. This one, the points of intersection. Points of intersection is a solution. And the one from the graph, let's put it in. So one point is 0, 3 clear on the y-axis, right? Right here. This point is 0, 3. They want this point down here now. Coordinates at this point. And you're estimating it, right? You have to be exact, correct, exact, precise. I'm wondering if it is right here. That point of intersection. That point would be 5.5, 5.5. Let's look at the scale. Look at the scale, the vertical scale. So right here says 1. Let's be careful. Right here says 1. It's 5 lines up to 1. So each of these is 0.2, 0.2, 0.4, 0.6, 0.81. So this is 0.2. Right? Each of these lines is 0.2. So this looks like 0.2, 5.5.2. I'm going to use this point. And so this point is 5.5 right here. 5.5, 0.2. But this point is clearly 0.3. This one is clearly 0.3. I want to give you those two points as my answer. All right? 5.5 and 0.3. 5.5, 0.2 and 0.3. So 0.3. Second point is 5.5, 0.2. I'd have to solve them actually simultaneously to find the exact precise values, but from a graph, these are the two values I'm getting from my graph. Give them what you get from your graph. Huh? That is it. Question done. Very good. Go and redo the questions, guys. Go and redo the questions. If you didn't get them, go and do them move on. Watch over the video, do the questions again. All right, number 7. Number 7, pattern question. This question says the sequence of figures made from lines of unit length and dots. So the lines form a series of octagons and squares. It says the dots are placed at each vertex. First 3 figures in the sequence are shown below. It says figure 3 of the sequence is shown by itself. Add lines of unit length and dots to figure 3 to correctly represent figure 4. So this is what is added to each shape. So what is added to each shape to go from this one to this one? What is it that is added? So they added this line and this line, and they added this dot. Then they added this line, this dot, 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 this line, this dot. This line was added. These dots were already there. This line was added, and this dot. This line was added. So these dots were already there. So that is what is added. This dot was also added. This that I've drawn in blue is what is added to each shape to get the subsequent shapes. Right? So you take this thing that I have in blue and you add it on, and you get this other shape over here. This is what was added. This is what was added to this. Or left off something. I left off this line was added as well. This line. So this is what they added. So if I identify what was added, see, that is what was added to form a second shape. And then added over here again to form the shape. So the same thing that we need to add down here now. See, add it down here. And voila, that's figure 4. Very good? Simple as that. Now I have the device, I cannot add it like that. You have to draw it. All right? You have to draw it. But that is what is added. All right? So that is a figure 4. Figure 4. And that's figure 4, guys. Figure 4. Done. Then we come to the table. So the number of dots D and the number of unit lines that form the perimeter of the shape P form a pattern. So the dots and the perimeter, they form a pattern in terms of the numbers. It says the values of D and P for the first 3 figures are written in the table below. So the pattern of numbers for each row and complete the rows numbered 1, 2, and 3. So I like to fill out this one first because it helps me with some of the top ones. The beauty about this one is that this is exactly the next shape. So whatever the pattern is with these numbers, you can continue to this line. You have to use the formula, but I like to complete the formula line first. So is this the type where you added the same number each time? This year I added 8, then I added 8 again. So this column starts with an 8n. Right? So this is 8n starts this formula. But the first figure is 8. So that is it. Formula is just 8n. Gotta keep adding 8, right? So the first here is just 8n. Over here, what are they adding? They added 6 plus 6. Add a plus 6 again. So it means that 6n starts a formula. But the first figure is 8. 6 times 1 is 6. You have to add 2. 6 times 1 up here is 6. You have to add a 2 to make it 8. So it's 6n plus 2. That looks like the formula to me. Those two formula. So this one now, you can add 8 again to this if you want, or you can take 4 and drop it on the formula. 8 4 is 32. So right here is 32. And here you can add another 6 if you want, because this added 6, or you can take the formula, it's 4 and drop it on here. 4 times 6 is 24, 24 plus 2 is 26. So I know you want to look at, this is 26. Then in this row, they tell you what this number is. They're going to equate these two. 6n plus 2 is equal to 86 in that line. So we can work out the n value. And then when we know the n value, we can work out this one afterwards. All right, so over here, this 6n plus 2 is equal to 86. 6n plus 2 is equal to 86 on this line. So we can know what the n is. So subtract the 2 over here first. We get 6n equals, subtract 2, we get 84. Then divide by 6. Divide by 6. How much again? Much that equal to? 13, 14, 14. Yeah, 6 4 is 24. Yeah, 60 and 24, 84. Correct. So 14. Now that n is 14. And take the 14 and drop it on the formula here. So it's 8 times 14. So this becomes 8 times 14. What's that equal to? 8 times 14. What's that again? 112. That's 80 plus 32. Yeah. 8 4 is 32. 8 10 8. Yeah. That's it. Under that two. All right. Table done. Down here, so now it says for any figure n greater than 1. Not up here, so. Talking about down here, so. For any figure n greater than 1. Down here, so, right? The number of dots D is greater than the perimeter. You can see it. The number of dots is greater than the perimeter. Up here, so them equal. But up here, so now them greater. Number of dots greater than the perimeter. You can see that is true. It said determine the value of n for the figure in which the difference is 36. And the difference is 36. That's what we call it. So looking at when D minus P is equal to 36. That's what they want. And the number of dots minus the number of P, that's the difference. That's the difference, right? When the difference is 36. And the dots minus the P, the dots minus the perimeter at 36. So basically then, when this formula for the D, 8n, minus this formula for the P, I put it in a bracket, 6n plus 2 is equal to 36. Is equal to 36. It's solving n for that. Open this up. Open up this minus. You get 8n minus 6n minus 2. So this minus and this to become a minus. Be careful. It's equal to 36. This becomes 2n equal to the negative 2 and carry it over here. So I add it, you get 38. If I divide both sides by 2, now you get 19. N equals 90. That is the answer right here. N equals 90. The difference is 36. But after that, very good. 2 marks for that. Question done. Question done. That's number 7. Let's go down now to number 6. Number 6 is a measurement question. It says, at a track meet, a cylindrical container fitted with a pipe, as shown diagram below, is used to serve water to athletes. The cylindrical container of radius 12 centimeters and height 20 centimeters completely filled with water, and the pipe fitted at the bottom dispenses water into cone-shaped cups. It says the cone-shaped cups have a radius of 3 centimeters and a height of 8 centimeters. See them here? And this up here, the radius is 12 and height is 20. Good? It's a measurement question. Question says, calculate the volume of water in the cylindrical container in liters. Write your answer to 2 decimal places. Note that 1,000 cm cube is a liter. So because all these dimensions are in centimeters, guys, we're going to calculate the volume in cm cube first, and then we shall divide by 1,000 to get it in liters. So the volume of a cylinder is pi r squared h. Area of the base, which is pi r squared times the height, pi r squared h. All right? They tell us what to use pi in this question as. When they don't tell what to use for pi, use the pi in the calculator. All right? So the volume of the cylinder is pi r squared h for the cylinder. For the cylinder, I'm talking about the cylinder. That becomes pi times the radius is 12 squared and the height is 20. Put it here, so. I said, don't get a lot of space. We're going to get it in cm cube first, and then we'll convert it to liters afterwards. Let's work it out here first. All right, so it's pi on the calculator, guys. Use a pi on the calculator. When they don't give it to you, use a pi on the calculator. So it's pi on the calculator times 12 squared times 20. So we're getting 9, that figure, we're getting 9047.79 cm cube. You divide it by 1,000. Divide it by 1,000 now to get it in liters. And that's how much decimal places say? Write your answer to 2 decimal places. That's 9.05 liters. 9.05 liters. Forget it. But I go to that. 9.05 liters. You divide by 1,000 to get it in liters. And I want 2 decimal places. So it's 9.05 liters. That's the volume in liters, guys. Remember, if we're working, doing the calculation, we're working in cm cube, just the same. Next part says, water flows from a cylindrical container along the pipes into the cone-shaped cups at a rate of 7.8 milliliters per second. This is not complicated. I want to point out to you that milliliter and cm cube is the same. 1 milliliter is the same as 1 cm cube. So this 7.8 milliliter is the same as 7.8 cm cube per second. All this means is that every second, 7.8 cm cube flows. That's all it means. 7.8 cm cube per second simply means that every second, 7.8 cm cube flows. In 2 seconds, it's 2 times 7.8. In 3 seconds, it's 3 times 7.8. In 4 seconds, it's 4 times 7.8. That's what 7.8 cm cube per second means. Every second is 7.8 cm cube flows. Important to know this, guys, that a milliliter and a cm cube is the same. Kind of makes sense because 1,000 milliliter make a liter and 1,000 cm cube make a liter. So it means that the milliliter and the cm cube is the same. But that's not it here. I give it this now. 1,000 cm cube is a liter. But 1,000 milliliters is also 1 liter. So if 1,000 milliliter is a liter, and 1,000 cm cube is a liter, it means a milliliter and a cm cube is the same. Right? 1 milliliter and 1 cm cube is the same. You never know before, make sure you know it. So when I give it this in milliliters, same as cm cube base. So we're good to go. We can continue working in cm cube. All right? And centimeters. It says calculate the time taken to fill one of the empty cone cups. Give your answer correct to the nearest second. So we need to know the volume in one cone cup, and we divide it by 7.8. That's the time taken to fill it, to fill it. But that's on that. So the volume of a cone cup, and that's the volume for a cone, 1/3 pi r cube. And we're talking about the cone now. So for the cone, the radius of the cone was what? The radius was what? 3 centimeters, don't it? And the height of the cone was how much? What was the height? That's 8. 8. The height is 8 centimeters. So the volume of a cone, or one of these cones, is 1/3 pi, the radius is 3, see, r squared. The radius is 3 times the height of 8. That's the volume of a cone. 1/3 pi r. 1/3. Should I split the screen and I'll put the screen? But anyway, 1/3. So it's 1/3 times pi times r, which is 3 squared, times 8. I'm getting 75.4. So 3 significant figures. That's 75.4 cm cube. And if you put in that 7.8 cm cube per second, and the time to fill it, if this amount, when it is full, divided by 7.8. But understand, you want to know how many 7.8 is in this amount. But understand that? So time to full is 75.4 divided by 7.8. Work that out and you have the things. I'm just going to divide this figure on the screen now by 7.8. And it's given me 9.66, 9.666 seconds. And if you correct the nearest second as approximately 10 seconds. So the nearest second is 10 seconds. That's approximately 10 seconds. And I'm saying, give your answer correct to the nearest second. See that? Nearest second means you roll it up to the nearest whole number. That's 10 seconds to take the full up. But understand that. But I write that 10 seconds to take the full up. Let me see if I can split the screen and still have us doing when I workplace. Let me see if I can split the screen. Then we can. All right, better. Sustainable. All right. That is it. Very good. 10 seconds. Next part now says, determine the number of empty cone cups in B that can be completely filled from the cylindrical container. So what it is now, the volume of one cone cup is that, right? And the volume of the whole cylinder, what was it? Is this in cm3, that. To define how many cone cups in, just divide them, don't it? Understand that? You divide the volume of a cone cup, the full cylinder, by the volume of a cone cup to see how many cone cups you're gonna have. Right? So the number of fills will be this divided by the volume of the cone cup. So remember now, the volume of the cylinder was that figure there. Let me copy it now. This whole figure here. So that's the volume of a cylinder. Copy and paste it down here. So. And the volume of a cone cup was this figure right here. Just 75.4 cm cube. Therefore, number of cups is this volume divided by this volume. Is 9047.79 divided by 75.4. All right, I will divide out those. I'm going to give the answer to the nearest whole number. So this could have been done also by dividing the formula, then, right? But using these values. So 9047.79 over 75.4. 120. 119.997, 120 that. 120. 120. Cups. 120 cups is what it takes. Completely empty the cylinder, 120. But all right, that is it. They completely empty the 120 cups. Number of cups is 120. That's it, 120. All right, let's go down to number 5, statistics. Number 5. This question says, the cumulative frequency diagram below shows information about the distance D that each of 120 students walk to school on a particular day. Remember, cumulative frequency graph resulting from the fact that you don't know the actual distance walked by the students. It's the best way of lining up the students in ascending order from the ones who walk the shortest distance down here with the shortest distance to the ones who walk the longest distance up at the top, the longest distance at the top. All right, so these are the 120 students. From the ones who walk the short distance to the long distance, from short to long at the top. And these are the distances that they walked less than or equal to. Remember, the graph either shows less than distance walked or less than or equal to distance walked. It has to show that because I don't know the actual distance that they walked. It shows how many students walk less than or equal to certain distances. That's what it shows. I show the distance that a number of students walked less than or equal to. You don't know which one it is until they start to read the question. And the graph can show either less than distance or less than or equal to distance. Give me the frequency graph. When you start to read the question, you'll know which one it is. All right? So This question says, how many students walk at most? Well, this is giving an indication, at most. At most means that amount or less. This means less than or equal to 1. That's what this means. This means less than or equal to 1 kilometer. At most, 1 kilometer is the most. It means less than or equal to 1 kilometer. That's what this means. Let me write it here, so. Less than or equal to 1 kilometer. Looks like that's a less than or equal to graph. So I'm going to put it here. It's a less than or equal to distance. That's what it shows. Based on this question. At most means that amount or less. 1 kilometer is the most. So it means you want to know how many students walk 1 kilometer or less. So the graph supposedly therefore is showing less than or equal to. So the number of students who walk less than or equal to 1 kilometer, you're going to come up on the graph, find 1 kilometer, which is right here. And you're going to see the graph going to show how many students who walk less than or equal to this 1 kilometer. Come up on the graph. Read it up to here. And then it's right here. Come across. And it's right here. And that looks like, and you have to read the scale properly. Read the scale properly. This is 20, this is 30. Don't just put in values. This is 20, this is 40. Is that right here? So it's 30. There are 5 lines here. Between 5 lines over an interval of 10. That's 10 divided by 5. Means that each interval is 2. So each interval is 2 students. Put it down here so we don't forget. Each interval is 2. This is 10 as well. And there are 5 lines here. So each line represents 2 students. This is 2. Put it here so you don't forget. Each line is 2. So it says 30, 32, 34. This is 36. Don't put 34, guys, or 33. This is 36. This is 36. The tendency is to read it as 30, 31, 32, 33. It will be wrong. That's 36. See, 30, 32, 34, 36, 38, 40. Make sure you get the scale right. That is 36 students. So 36 students walked at most 1 kilometer. So the answer down here is 36 students. I don't make any adjustment. So 36 students is the answer. So 36 students walk less than or equal to 1 kilometer. 36 students. Next question says, using a cumulative frequency diagram, determine an estimate. Remember, I can only estimate from a cumulative frequency graph. And the data is ungrouped. I don't know actual distance at the walk. The median distance. The median distance. That's a distance walked by less than or equal to half the number of students. So since there are 120 students, the portion of the median is a 68th student right here. Halfway mark, half of 120. Total number of students, 120. So 60 is the position of the median. This is the position of Q2. That is not Q2, that's just a position of Q2, the 68th student. Want to find the distance that 68th student, that 67 students walk less than or equal to. So you come across on the graph. And you read that mark down here. Read it down. Looks like it is right here at this mark. Again, you have to make sure you get the scale horizontally correct as well, in horizontal scale. Let's look at it. It's 10 lines out to 0.5. So each mark is 0.5 divided by 10. So each mark is 0.05. So every 2 mark is 0.1. So every 2 mark is 0.1. If every mark is 0.05, every 2 marks is 0.1. So see here 0.1, 0.2, 0.3, 0.4, 0.5. So every 2 mark is 0.1, 0.1. Every 2 mark is 0.1. What I say that? 0.2, 0.4, 0.6, Sorry. Every 2 marks is 0.1. So 0.1, 0.2, 0.3, 0.4, 0.5. So it's consistent. Every other mark is 0.1. But I understand that. Every mark is 0.05. You have to get the scale right before you start to work. So every other mark is 0.1. So let's go there. So this is 1. Right? It should be 1.1, 1.2. This is 1.3. 1.4, 1.5. So you correct that this is 1.3 right here. This mark is 1.3. That is your Q2. So Q2 is 1.3 kilometers on the graph. The median Q2 is 1.3 kilometers, just like that. Then I want the lower quartile. Lower quartile, remember, is the distance that 1/4 of the students walk less than. Or less than or equal to. So the portion of Q1 is halfway between at the bottom half. Halfway between 0 and 60 is 30. So right here, the position of, right here, 30 is the position of Q1. Position of Q1, the 30th student. 1/4 of 110. They do the same thing. You come across to the graph. They come across on the graph at 30 here. And you read that distance, read what the distance is down here. It looks like right here. Right at this mark is Q1. Again, remember, every other mark is 0.1, right? 0.5, 0.6, 0.7, 0.8 is 0.9. 0.9 and then 1. So right there, 0.9, that is your Q1. 0.9 is Q1. All right? 0.9. Right, that point. 0.9. So Q1 is 0.9, lower quartile. Q1, 0.9 kilometers. Then I want the interquartile rate. Find the interquartile rate is Q3 minus Q1. So we need to find Q3. Right? So Q3 right now, we don't know it yet. Q3, we'll have to find Q3. And then subtract Q1 from it. So we need Q3 first. Let's go and see what Q3 is first. Right? And then the interquartile rate that they want is going to be Q3 minus Q1. We're going to have to work it out. But let's find Q3 first. So Q3 now is halfway on the top half. Halfway between 60 and 120 is 90. Or you can say it is 3/4 of 120. 3/4 or 75% of 120. Anyone want to work out that is 90. I can say it's halfway on the top half. Halfway between 60 and 120 is 90. That's a position of Q3, the 90th student. All right? Or 3/4 of 120. Anyway you want to look at it, it is right here. 90th student. All right? That is the position of Q3. So again, I come across on the graph right here. And you read it down on that one. You're reading it down on this line, you know. So based on that, it is right here. Careful now. That's only 1 mark after the 0.15. Remember, here will be point, here will be 1.6. Right here will be 1.6. So right here, that will get is 0.5, 0.05 after the 0.5, after the 1.5. So this is 1.55. That is the Q3. 1.55. That mark is 1.55. But I get that? Because here, will be 1.6. Right? It's halfway between 1.5 and 1.6. That's 1.55. Remember, every line was 0.05. Every other one of those small lines on the horizontal axis was 0.05. The right there is 1.55. So it's 1.55 is Q3. All right? 1.55 is Q3. So Q3 is 1.55. So let's write it down. So Q3 right now is 1.55. So the interquartile range then is 1.55 minus Q1, which is 0.9. And you work that out with the calculator. There's 1.55 minus 0.9, that's 0.65. 0.65, that's 0.65 kilometers. Remember, all the measures are in kilometers. All the measures are in kilometers. Next one says, a student is chosen at random. What's the probability that he walked for more than 1.5 kilometers? So the graph is going to show you how many walk less than or equal to 1.5 is the rest of them that walk more. But understand that? So see you know, less than or equal to 1.5 kilometers first is what you're going to get first. Is how many students? The graph is going to show you that. The rest of them walk more. So the graph is going to show you this. The rest of them walk more. So 1.5 is here. So 1.5 here. So this is a different color. 1.5 is here. 1.5. The graph is going to show you who walk less than 1.5. The rest of them at the top walk more. So the ones who walk more are the ones who walk the distance up here. So representing above it, of the top, what the people at the top. All right? So the graph is going to show you how many walk less than or equal to 1.5. You want the ones who walk. So to 1.5 line here, so now you pop on the graph, 1.5, this line here, so that's right here. And then you read it across. It's right here, right here. And you read it across here. That's 82. Remember, every one of these lines was 2. That's 82 students walk less. Right here, 82. 82. And the rest of them up to 120 walk more. They become 120 minus 82. 82 walk less than or equal to 1.5. The rest of them walk more. So that's 82 walk less than or equal to 1.5. See here? 82. It's 82. Therefore, greater than 1.5 kilometers. That's what this means. More than 1.5 means greater than 1.5 is 120 minus 82. Much is that? 120 minus 80 first is 40 minus 2 more is 38, don't it? 38 students. That's his answer. 38 students walk more than 1.5. That's what I want. Graph shows you how many walk less than or equal to 1.5, but you really want it those who walk more. The graph shows you that it's 82 walk less than or equal to 1.5. The rest of them walk more. 120 minus 82 is 32 students. Very good. Very good. 32 students at the top walk more than 1.5. Now come down here, son. Table. Question says, complete the table below and use information to calculate an estimate of the mean distance walked by the students. All right. So here we have the midpoint values. So look here now. These lower limit going up by this upper limit going up by 0.5. Well, upper boundary those are. These lower boundaries also going up by 0.5. So the midpoint will also increase by 0.5. So to go from here to here, just add 0.5. So it's going to be 1.75. But understand that. Just add 0.5. Everything increasing by 0.5. So just add 0.5. Then now to get the number of students, we can look at the table, look at the graph, and see how many students in between 1.5 and 2 on the graph. Huh? Well, I'm going to show them how we get from the graph. And then how many students between 2 and 2.5, right? So let's look at the graph. So we know that at 1.5, we had 82 students. Let's use for the others now. 1.5. And then at 2, we're going to look how many students correspond to 2 kilometers on the graph. So 2 kilometers, let's see what that is. 2 kilometers right here, up on the graph, this point, right? It's right here. And you come across that it's right in between here. So and read what that is. This is 100, this is 110. Remember, this is 102, this is 104. So right is actually 103. 103. All right? So 103 corresponds to 120. So in between this and this, it is the difference. In between this and this, it is the difference. Remember, this was 1.5 and this was 2 kilometers. 1.5 kilometers and 2 kilometers. The number of students in between is 103 minus 82. But understand that? So it's actually 21 right there. 103 minus 82. The number of students in that interval between 1.5 and 2. So in between here is 103 minus 82. That's 21 students I'm getting, 21. And then now you want to know me between 2 and 2.5. So let's go for the 2.5 line. So many students here. 2.5. 2.5 here. So it will basically be on this line, up to here. So read it up to here. And then you come across and read it over here. Just read up to here, which is 118. This is 118. Means that there are 5 students, 15 students in between this. From 113 and 118, that's 15 students. That's right? No, it's not 110, it's 113. 113. My mistake. 113. 113. Correct this down so 113. So it's 5 students inside this. My mistake. 113 minus 82. 113. 113. So it's not right. It's 113. 113. That's 31. 31. 31. And then in between it says 5. 5 becomes 118 minus 113, which is equal to 5. And we can check if it's correct by adding up all of these. It must equal 120 if it is correct. Right? So total students must be 120. If I add up all of these, so check if it is correct. Let's see. Total number of students. Let's double check that. All right. So this exercise, guys, so you get the values from the graph for this example. 12 plus 24 plus 46 plus 31 plus 5 plus 2. 120. See? 120 is the total. So you know that these values are correct. See that, mom? Must add up to 120 here though. So go and do it over if you never do it, if you didn't get it, go and do it over again. Look at what I did. Put what the values are at the various marks, at the 1.5, at the 2, at the 2.5. Put what the values are. Right? So this one was for 1.5. This one was for 1.5 kilometers. This one was for 2 kilometers. 2 kilometers. And this is for 2.5 kilometers. So in between here is the interval between 1.5 and 2. That's 130 minus 82. Then between 2 and 2.5 is the student between 118 and 113. That's 5 students. See that? That's how you do it. Go and do it over again. Practice it. I told you to read the intervals from the graph. That's how you do it. All right? And everything must be consistent. That's it there now. They all add up to 120. You can trust these values. All right? So we're completing this table now. You get the value over here, multiply this times this. You get the value here. I multiply this times this to get the value here. All right, so let's go. So multiplying 1.75 and 31. 1.75 times 31, that's 54.25. And then it is 2.25 times 5. 2.25 times 5. That's 11.25. And then now, see this right here, the sum of f. So the sum of f, which is the n, is 120. And here now one, the sum of fx, the sum of all total distance by all 120 students. We're going to do sum of fx now here. So adding up all of these values now, add them up. So there's 3 plus 18 plus 57.5 plus 54.25 plus 11.25 plus 5.5. That's 149.5. So the mean distance walked is this divided by this. So the mean is approximately equal to the sum of fx, sum of the sum over the sum of f, which is the n. So 149.5 over 120 students. So the average distance walked by a student is this. 149.5 over 120, which is 1 point. I'll give it the three significant figures. 1.246 kilometers. Let's give it that. 1.24. So what is giving us on the graph, on the calculation here? Giving us 1.2458 and the 3 repeated. So I'm correcting it to 3 decimal places. 1.246. We put 1.25, 3 significant figures, they give it a marks as you see. I'm giving 1.246 kilometers. That's it. But all right, that, let's stand done. Body good? Online, body good? Nobody here to you now?
Yes, sir. Yes, sir.
All right, beautiful.
Yes, sir.
So guys, remember how we got the values in the table from the graph. I want to go and practice it. Or you get the values in the table from the cumulative feature of the graph. You need to go and practice it. All right, getting values. We're all familiar with going from table to graph. You have to know, learn how to go from graph to table. This is a perfect example of how you do it. So go and redo the question for me, please. And do it again. All right? All right, let's continue. That's number 4 now. Number 4. I suppose we can move fast now, but just easy question. Number 4, functions. Well, all the questions are easy on the paper, but these we can move much faster than this. Give us f of x, g of x, h of x. First part wants f of half. We're going to take half and put it in the f function right here. So it simply becomes 2 times half minus 1. That becomes 1 minus 1, which is 0. What I got? 0 is the answer. Because 2 times half is 1. Then they want h of 0. Means they're going to put 0 in the h function right here. So h of 0 means 5 to the power 0. Anything raised to the power 0 is 1. Put in the calculator and get it anyway. Any number raised to the power 0 is 1. Next one they want is g squared of minus 3. You have to remember now that this means g of minus 3. G of minus 3. What is g of x again? G of x, remember, is, let's write it what it is again. Is this one, 3x plus 2, right? Is 3x plus 2. So we're going to work out this part first, the g of minus 3 first, by putting minus 3 in the function. So it's going to become g of, I put the minus 3 in this function first. It becomes 3 times minus 3 plus 2 first. This is minus 3 plus 2, minus 9, sorry. Plus 2 is minus 7. So you do know g of minus 7. So g of minus 7 means you're going to put minus 7 in the g function again. It's going to become 3 times minus 7 now plus 2. That's minus 21 plus 2. That's negative 19 is the answer. Negative 19 is the answer right there. But as on this working out, key thing to remember is that g squared means g of g. Right? And g of minus 3 means you can work out the g of minus 3 first. That works out to negative 7. They do the g of negative 7 afterwards. And you get the final answer of negative 90. But I good? But I good?
Yes, sir.
All right. Then I want us to get g of f of x in the simplest form. Let's work them out. The g, remember, is 3x plus 2. And the f function is 2x minus 1. This g of f, remember, it means f into g. Remember? It means they put the f function into the g function. That's what it means. How you do that? You take all of this f function and simply put it into the g function right here where the x is. That's how you construct the g of f. Therefore, g of f, you can put in by the of x now. Neither here nor there. Is equal to, just do this construct. Put the f into the g. So it's 3 times where the x is to put in all of the f there. 2x minus 1, and then add back this 2 plus 2. See? Where this x was up, place all of the f there. And then simplify it. Becomes equal to, expand this first, you're going to get 3 times 2x is 6x. You're going to have 3 times minus 1 is negative 3. Negative 3 plus 2 will become negative 1. So that is minus 1. That is the answer right there. This is the answer. But I go to that, 6x minus 1. So to get minus 3 plus 2, negative 1. But I go to that. All right.
Yeah.
Next part. Once g to the minus 1. What is the g again? The g is 3x plus 2. So the g, let's start. I find it. The g first is 3x plus 2. I'm going to inverse it. Inverse it. So the g becomes x 3 times the x becomes g to the minus 1 plus 2. That's what happens when you form the inverse function. Then transpose it to make this a subject. Transpose everything from it. Here over the 2 first, we get x minus 2. Then take this 3 and divide it under there. Divide it under there. That is the g to the minus 1. That is it. We're going to, therefore, g to the minus 1 is this. It's x minus 2 over 3. You can put in by the half x here, so no. Let's put it back in. See g to minus 1 of x is equal to that. That is the answer right now. But good? But okay with that?
Yes,
All
sir.
right. Beautiful. Next part. Hence, or otherwise, determine this. G to the minus 1 of x equals 4. This can be done two ways. Okay, so if g to the minus 1 of x equals 4, we can put this equal to 4 and solve it. Right? Put that equal to 4 and solve it. So let's do that. We're going to put the x minus 2 over 3 equals to 4. Or the g of x is this. So you can say, i.e., that is g to the minus 1 of x equals 4. And solve this fine. Multiply across 3 first, we get x minus 2 equals 4 times 3 is 12. So you get x minus 2 equals 12. You take the 2 and carry it over and add it. So you get x equals 14. So that's one way. Or you can do it another way. If g to the minus 1 of x is equal to 4, then x is equal to g of 4. If g to the minus 1 of x is equal to 4, then I can take the inverse of g on this side, which is this becomes g. The inverse of g to the minus 1 is g. If g to the minus 1 of x equals 4, then x equals g of 4. So you could work it out that way, g of 4. So you can put 4 in the g function right here, so you get the same 14. See? It become g into this. From 4 into that, become 3 times 4 plus 2, which is the same 14 that we got. So it's a second method we could have used. This is a second method. This is the OR method. Same answer. What about it that? Yeah? Question done. Next question is number 3, right? So number 4 a while ago. Number 3 now. Nice and easy. Diagram. The box below contains the name of 5 quadrilaters: trapezium, rhombus, kite, square, rectangle. Choose the name of one quadrilateral from the box that best completes each statement. Something, one of these, has no line of symmetry and has rotational symmetry of order 1. Let's talk about rotational symmetry again. Rotational symmetry is the number of positions when rotating an object about its center, it gives about the same shape. The number of times it gives about the same shape. All the way around to a 330 degrees rotation. 360 degrees rotation. The number of times it has the same shape. I'll give you an example. Let's say we have a rectangle like this. I rotate in this rectangle about this center point here. So I like to rotate it 90 degrees, 180 degrees, 360 degrees. How many positions up to 360 degrees will it have the same shape? But when I rotate it 90 degrees first, it's going to shape like this. It's not the same as the original shape, don't it? That's 90 degrees. When I reach 180 degrees, it comes back to the same shape, don't it? That's after 180 degrees of rotation. Comes back the same shape, don't it? For rotating it. So that's order 1. So I'm going 1 already. Right? Order 1. Then we rotate it again, 270 degrees. So we rotate it again. It's going to get back to the shape again. That's after, so 180 degrees, it has at 180 degrees, it matches, right? So order 1, right? That's order 1, right? At 270 degrees, it don't match, right? So you don't count that, right? You count each time there's a match. When we rotate it 360 degrees, it's going to come back to the original shape. Erase it. I want to keep this. All right, so it matches at 180 degrees. That's order 1. At 270 degrees, all right, 90 degrees, there's no match, right? At 180 degrees, there's a match. At 270 degrees, there's no match. When we rotate it again and reach 360 degrees, it comes back to the original shape, don't it? That's another order. So the rotational symmetry for a rectangle is order 2, because there are 2 positions that it matches the original shape. But understand that. But understand that? Let's try another shape. If we had a square, and rotating this square about the center point, turning it. At 90 degrees, it match, don't it? The original thing, don't it? If you rotate in this 90 degrees. At 180 degrees, the content, it match again, don't it? At 180 degrees, it come back to the same shape again. At 270 degrees, it match again, don't it? And at 360 degrees, after I rotate this 360 degrees and come back to its original position, it match again. So a square has rotational symmetry of order 4. Let's take a equilateral triangle. An equilateral triangle. 3 equal sides. I'm rotating it about here. Just imagine that you take this and you're spinning it around, rotating it. Right? But I get that? It's going to have 3 positions in which is in the same order. 3 times. 3 times going to be the same, look the same. When this point rotates to here, that's 1. When this point is now rotated to here, that's 2. And when I rotate and come back to the original position, that's 3. So a triangle has 3 positions in which when you're rotating it, it looks exactly the same as it was before. It's just that we're going to be rotating this like 120 degrees at a time. 120, 240, and 360. Those are the positions in which it will be exactly the same. At 120 degrees rotation, 240 degrees rotation, and 360 degrees rotation. Every 120 degrees it looks the same. That's that equilateral triangle. But I go to that. What about a circle? What do you think rotation symmetry for a circle is? A circle. A circle. That over a circle. What do you think rotation symmetry for a circle is? Infinite. There's that infinite number of positions that you can rotate it. That will look exactly the same. See that? An infinite number of positions that you can rotate this. And it will look exactly the same. So the order is infinity for a circle. Right? So basically, it's the number of positions that you can put it in and fit it on its original position and look exactly the same. All right? So let's look at these. So this one wants it to have no line of symmetry. Which of these shapes have no line of symmetry? It's the only one that can have no line of symmetry, you know. It can have a line of symmetry, but it don't have to. A trapezium that looks like this has no line of symmetry. You can have what we call an isosceles trapezium, the one that looks like this. Then you can have a line of symmetry here, down the middle. See that? See this? See that? A kite has a line of symmetry. A kite shapes like this. The line of symmetry is this. And I said the order of symmetry is order 1. So every shape has at least 1 position where it is exactly the same. That is at 360 degrees. If you rotate something 360 degrees, it will automatically have the same as its original shape. But understand that? If you rotate something 360 degrees, it must come back to its original shape. So every shape has rotational symmetry of at least order 1. So it's always 1 or more. Because at 360 degrees rotation, it must come back to the original shape at least 1 time. When it comes back to the original shape. Get me? So the order of symmetry of every shape is at least 1. So I would say the answer for this one, by a process of elimination, by looking for the one that has no line of symmetry, would be this one. A rhombus has at least 2 lines of symmetry. A rhombus is like this. It's a parallelogram with 4 equal sides. So a line of symmetry here A line of symmetry here. A rhombus. 4 equal sides. All right? Everybody know a square. Square has 4 lines of symmetry. A square has 4 lines of symmetry. See them here? This, and that. Right? 4 lines of symmetry. So you could not be talking about them. So the best one must be the trapezium. A trapezium can have a line of symmetry. It is an isosceles trapezium, but it doesn't have to have. So the answer, best answer for this, so I put the word best, is the trapezium. Everybody know a rectangle has more than 1 line of symmetry, right? That's 2. Rectangle, the line of symmetry here, 1 there. So we're talking about the one that has 1 line of symmetry. Trapezium. Which is the answer for this one. This one says has exactly 2 lines of symmetry and 4 right angles. That's a rectangle, don't it?
Yes, sir. Yeah.
And this one has 1 line of symmetry, but no rotational symmetry. Well, when I say no rotational symmetry, that is when it has order 1. It's a kite. This one's a kite. 1 line of symmetry. That's a kite. When it has no rotational symmetry, it means that the order is 1. The order is 1. So in other words, that rotated 360 degrees for it to come back to its original position. Right? And they say that no rotational symmetry, means that the order is 1. But go to that, get those 3 marks. You come to this one now. Says the diagram below shows 4 lines, 2 of which are parallel. So the parallel lines here, and they are crossed by this one. That's a transversal line. Another transversal line. So remember, when you have these parallel lines crossed by a transversal line, you have Z angles forming, co-interior angles forming, corresponding angles forming. And you have vertical opposite angles forming. All these kinds of properties you have forming. All right? This question says, determine the value of Q and R. Well, R looks like it's the easy angle to find for me first. But these 2 angles are vertical opposite, them equal, right? Those 2 angles are equal. So R equals 54. I'm going to write down that first. They are vertically opposite. So this angle here is 54. Then these 2 angles now are co-interior. See them here? This one and this one parallel. And they are connected with this transversal line. So these 2 angles are what we call co-interior angles. See that? They are up to 180 degrees. They're like angles in the base of this U. They're up to 180 degrees. So I'm going to say that the Q is 180 degrees minus the R. So it's 180 minus 54. That's what the Q is. 180 minus 54. 2 of them add up to 180. They are 4 interior angles. The question I've asked for no reason. Just for us to calculate that. So much is that? 126. 126. Note I'm not putting any degree on them. Or the question are degrees on them in the diagram. Right? So since the degree is already on this, the R is just a value of 54. Right? So I'm not putting any degree on them. That one done. Said now, give a geometrical reason why angle P is 71 degrees. Angle P is 71 degrees. This and this equal. Alternate angles then now. See here. Down this parallel line. Down this parallel line. You jump across on this one. See that? Connected there. So that's alternate angles. These 2 angles are alternate angles. Alternate Z angles are equal. That's the reason. Alternate Z angles are equal. That's the reason. Alternate, what we call Z angles are equal. They're alternate angles. That's why they're equal. Here now, diagram below shows triangle, the prime triangle and the double prime triangle. So this is the prime triangle, that's the double prime triangle. So these are already transformed from another triangle. It's not shown, right? It says The prime triangle XYZ is the image of triangle XYZ after an enlargement of scale factor 2 about the point 51. Remember, enlargement applies to the size of the object and also to the distance from the center. A lot of the time, it's the distance from the center that is more useful. So the center point is 5,1. I'm going to put it on the diagram, but the center point is 5,1 is right here. So from this point, there's an enlargement of scale factor 2 from a triangle up to this triangle. So it means that the size was doubled and the distance was doubled. So to come back to the original triangle, we just need to half the distance. See that? That's half the distance of the points. So for example, the distance from the center to here was doubled. We need to half that distance. Half of that distance, half of this line would be right here. See, this length and this length is the same. So it means that this point was here originally. So that's where the y prime, y would be right here. Half the distance. See, you can see that this length and this length is the same. I can look at it this way. That red line is 1, 2, 3, 4, 5, 6 diagonals. So half of it is 3 diagonals. 1, 2, 3. So this point was enlarged, doubled. That distance was doubled out to this distance. So this is where the y was. Now we can draw the rest of the shape. But this length was doubled, so the original length was half of this, which is 1 unit to here. So this is where the x was, right here. Right here. And again, this distance was half. It was doubled to this, so half of it was original. So this is 4. The original length was 2 here. So this is where the z was. And then complete the triangle. That's it. If I put in back this construction line, they can see. If I put in back this line from here to here, you can see it pass through that point. And then from here to here, same thing. So those are construction lines for the enlargement. So this is your original triangle. All right? Simple as that. X, Y, Z. So let me take these out. So I've drawn that object, right? So draw X, Y, Z, the object. I will label it as well. Next one says, the prime triangle is mapped onto the double prime triangle and reflection in a line P. State the equation of line P. So one, the line must be halfway between the two triangles. So the mirror line is halfway between this and this. So for example, halfway between this point and this point. What is this length? That's 1, 2, 3, 4, 5, 6. Halfway mark is 3 from it. 1, 2, 3. So the mirror line would be right here. Let's do this one down here as well. From this to this, mirror line is halfway. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The mirror line is at 5, halfway. It should be 1, 2, 3, 4, 5. Let's go again. Let's go again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Mirror line is going to be 5. 1, 2, 3, 4, 5. So this is not right then. This line is not right. This is 3 I want. 1, 2, 3, right here. Right here. And right here. All right, so the mirror line is under those 2 purple marks. So the mirror line is on those 2 purple marks. This is this vertical line passing through 2. That is x equals 2. A vertical line passing through 2, x equals 2 is the mirror line. And I want the equation of it. That is line P. This is line P. It's x equals 2. All right. And I want the equation of it. It's x equals 2. Vertical line 2, 2. Done. All right. Number 2. And then number 1. Number 2. Factorize this completely. That's a common factor factorization. Let's put the highest common factor. In terms of the numbers, the highest common factor is 3. And the variables is n and n squared. Common factor of n and n squared is n. There's no common factor p. So 3n is a common factor. 3n divided out of that people with an n. 3n, 3 out of the 5, out of the 50 limit of 5. This n is already factored out. And we have the p left. We're not sure we can expand it back. This time this, give me back that, which is good. This time this, give me back that, which is good. So that is the factor. And then inside you can factorize them further. And you cannot factorize them further, so it does. This question says, diagram below shows a quadrilateral with lengths of its side in terms of x. These are all in terms of x. Those sides are in terms of x. It says, write an expression in terms of x for the perimeter of a quadrilateral. Express your answer in the simplest form. So basically adding them up. So I cannot add up the value, x values first. You can add them up as they are on the table. You can write them down. So it's 2x plus 2x minus 1. 2x minus 1, that's right here. This one. Then 15 minus 2x plus 15 minus 2x plus this one is 3x minus 7 plus this one is 2x plus 5. Simplify. That is, this 2x and this 2x wipe out each other. Therefore, 2x and 5x, 3x and 5 and 2x is 5x. The numbers no. The numbers no. The numbers no. So this is 15 minus 1, that's 14. 14 minus 7 is 7. 7 plus 5 is 12. That's it. Want to get that? 5x plus 12. All right, that's the answer. In simplest form, 5x plus 12. Question said the perimeter is actually 32. So it means that equals 32. Find the length of the longest side. So we need to find the x first. And then we need to decide which one of these is the longest side. All right, I don't want to go by looking. This looks like the longest side, but I don't want to go by looking. Or this one of those two. But I don't want to go by looking because maybe not drawn to scale. Let's find the x first. So we said this equals that, right? So we had 5x plus 12 equals 32. Subtract the 12, we get 5x equals 32 minus 12 is what? 20. Divided by the 5, we get x equals 4. X equals 4. All right, let's write on the sides now. Just to make sure. So the 2x minus 1 is 2 times 4 is 8 minus 1 is 7. Then the 15 minus 2x is 50 minus 8, right? That's 7 as well, right? That's 50 minus 8. That's 7 as well. Then 3x minus 7. 3x minus 7, that's 3, 4 is 12 minus 7, that's a 5. And then 2x plus 5. 2x plus 5 is 2 4s, 8, 8 and 5 is 13. That's the longest one, right? 13. Again, do they add up to 32? Let's double check that. Make sure we have everything right. So it's 7 plus 7 plus 5 plus 13. 32, good. So the longest is 32 centimeters. Longest side is 32 centimeters. Not even 32, 13. 30 is the longest, 30. The longest side is 13 centimeters. Very good? All right. What else? What else? What else? This one says we have to determine all the integers. Integers are positive or negative whole numbers. Which satisfy this inequality. First, we want to transpose and get x alone in the middle to take into what the range of values are. So you can transpose everything away from the x. Remember that's an inequality. So if you multiply or divide by a negative number, you have to reverse inequality sign, right? So you're transposing everything away from this x. Let's get rid of this 3 first. I'll get rid of that 3. Multiply 2 by 3. Multiply everything by 3. So multiply 2 by 3 first. Get rid of this 3. Multiply this by 3. Become negative 3. Less than, this stays up here because you're going to cancel away this 3 here. So you're going to have 2 minus 4x. Less than, multiply this by 3, becomes 15. They want to get rid of this 2. So you subtract 2 from all sides. Subtract 2 next. So multiply by 3 first. Now we're going to subtract 2 to get rid of this 2. Subtract 2 from all sides. So subtract 2 from this side, it becomes negative 5. Less than, you have minus 4x left inside here. Note it is not 4x. It's minus 4x. Less than, subtract 2 from this side, you get 13. What to go to that? Then to get rid of this negative 4, you have to divide 2 by negative 4. When you multiply and divide by inequality with a negative number, you have to reverse the inequality sign. So now, we want to divide by negative 4. Divide by negative 4. But because we divide with a negative number, we have to reverse those 2 less than signs. All right? We divide this by negative 4, becomes a positive 5 over 4. This sign is reversed to a greater than. Divide this by negative 4, it becomes x. This sign is reversed to a greater than. Divide this by negative 4, it becomes negative 13 over 4. See that? So x is between these 2 values now. Let's put them in decimal so we can see them more clearly what they are. Let's put them in decimal. I don't want the whole number. So this is 1 1/4. 5 divided by 4 is 1.25, right? It's 1.25. It's greater than x. It's greater than this one now. That's 13 divided by 4. That's 3.25. Negative 3.25. All right. So I want us to understand this clearly, what this means. Now, this inequality can be spun around because this is the lower value. So it means that x is between negative 3.25 and 1.25. So I can write it this way, i.e. negative 3.25 is less than x, and x is less than 1.25. So it means that x is between these 2 values. I want the whole numbers. Therefore, to show this on a number line, right? I have 1.25 here, so this is 1 1/4. And I have negative 3 1/4 down there, so that's what 3.25 is, 3 1/4. Negative 3 1/4. It means that I would have 3 right here, so that different color. 3, negative 3 be inside here, and negative 1 and 1 will be inside here. See that? This should be 0. Right here is my 0. So this interval that I have here would not include this, not include it because there's no equal on it. And I'm going up to here. That is that interval. That's what this represents on a number line. We have placed an unshaded circle on the 1 1/4 and an unshaded circle on the negative 1. I want integers only. So it means that I only want the whole numbers in this range. The smallest whole number is negative 3. The largest whole number is 1. I want all the whole numbers in between here. So I would want -2, -1, 0, and 1. So those are my whole numbers. See that? See that? Whole numbers in this range will be these. That's what the integers are. So for this answers, my integers will be x equals -3, -2, -1, 0, and 1. Those would be my integers. The whole numbers inside that range of values. So I'm showing the number line for you to see what the range of values are. This will be my number line. Unshaded circle on the -3.25 down here, because there's no equal on that. And an unshaded circle on the 1.25, 1.25 is 1.25. And the whole numbers in that range are these that are marked in purple. Those are the whole numbers. Integers are positive and negative whole numbers. So those purple numbers are my whole numbers within that range. So these are the integer values. This is my answer. Right here. Yes, I'm done. -3, -2, -1, 0, and 1 are the whole numbers in that range. You can understand that, guys? Understand? The whole numbers in that range are the -3, -2, -1, 0, and 1. That's what integers are. Integers are negative or positive whole numbers. That's what integers are. I only wanted the whole numbers in that range. All right? Next question. Number 1, next, I never do. Number 1, I never do. Calculate this thing with a calculator. So just make sure you have a good calculator, guys. Textbook display calculator, and just put it in there. So putting this in the calculator, right? So it's a fraction. We have 8.9 plus 31.6. Put that over 0.75 times, that's 5.4. 10 is equals 10. That equals 10. Next question. The value of this to 1 decimal place. Same thing, put it in the calculator again. That is equal to put in the calculator. That's 3.9 times the tan of 8. Make sure you calculate in degrees. So the DEG at the top of my calculator here, DEG at the top of it, meaning that it is in degrees. That works out to 1 decimal place I wanted to. We get 1.267 to 1 decimal place is 1.3 to 1 decimal place. 1.3 to 1 decimal place. But remember, this down. Whoever gets first. So we're getting calculator giving us 1.267 1.267 and so on. 1 decimal place is right here. 6 correctly 2 make it 3. 1.3 to 1 decimal place. Done. All right. Next part said. It says Rhea is paid at a rate of $13.50 per hour during a certain week. She worked 40 hours. How much did she earn that week? She earned 40 hours times $13.50. Simple as that. 40 hours times $13.50 per hour. Simple. 40 times 13.5. $540. $540 to earn that week. For that 40 week. He said, we are work 4 weeks in a month of August, and her gross pay was this amount for the 4 weeks. Remember, every week she earned 440 regular pay. He says her regular work is 40 hours, so that's our regular pay for 1 week. This amount. So the 4 weeks I earned 4 times that as regular pay now, 4 times that as regular pay in the 4 weeks, right? So the rest of it is overtime. And she is paid time and a half for overtime. For overtime, she's paid time and a half, 1.5 times. So 1.5 means 1.5 times this. It's overtime pay. Let's write it down. Now the overtime rate. Let's write it here. So the OT rate is 1.5 times the 1350. That's the rate for overtime, which is equal to what? The overtime rate. So it's 1.5 times 13.5. So it's $20.25 per overtime hour. Every time you do overtime, that's how much you get per hour overtime. All right? It says, show that we are 15 hours overtime in August. That's the total pay in August. So we need to find out what the regular pay was in August and subtract from that to know what the overtime pay was, right? What the overtime pay was in August. So see here, watch this now. The overtime pay or the August overtime pay is equal to the total that you got, which is 2463.75 minus 4 times the regular pay. It's 4 weeks you worked in August, right? 540. But I give it that. That's the overtime pay. The total pay minus the regular pay. The regular pay is 540 per week. And she worked 4 weeks. So that's what we're working on. So the overtime pay is 2463.75 minus 4 times 540. So she worked overtime $303.75. That's overtime pay. Now, at this amount of money she's earning it at this rate, overtime rate, $20.25. So to know the number of overtime hours she did, you divide this by this. Overtime pay divided by the overtime rate with the overtime hours. So see here now, the OT hours equals the OT pay divided by the OT rate. OT means overtime. So that is 303.75 divided by the overtime rate of 2025. I'm sure that it's work out to 15 if you work it out. That's the answer. Sure say if you work it out, you get the 15. 303.75 divided by $20.25. 15 flat. So the 15 hours overtime. That is shown, right? That has been shown. 15 hours. Next part says, in August, 20% of the gross pay. What is the gross pay again? Gross pay was this figure right here. So that's the gross pay. So 20% of the gross earning was deducted as tax. How much money does she have left after deduction? She has 80% left. If them take off 20%, she has 80% left. So amount left equals 80% times the gross pay. of 2463.75. If you take off 20%, you have 80% left. Simple as that. Don't complicate it. So 80% is 0.8. I can put it 80% on the calculator. 80% times 2463.75. So she has $1971 left. That's the answer. All right, so she give up 20% the tax. So she have 80% left. He said, Rhea invests $290 of her earnings for 3 years at a rate of 4.5% per annum simple interest. How much interest does she receive after 3 years? Simple interest equals PRT divided by 100. That's how we need to remember. Formula. PRT over 100. This is the P, principal amount. This is the time in years. This is the rate to give it the interest. Simple as that. PRT over 100. This equals the principal is $219 times the rate of 4.5. 100 under you is taking care of the percentage in that rate. That's what the 100 under here for. Times the time of 3. Put that in the calculator, you have the answer for the interest in dollars. Let's work it out. So the fraction, that's 219 times 4.5 times 3, and dividing that by 100. That's 29 in money. Let's call it 29.57. That's 29.57. Let me shift this over somewhere. That's 29.57. That is the answer right here. That is the answer right here. But all right, online, body good? Body good online? All right, that was the paper, guys. We are done. And they run away. We're not going to tell me what you're getting on the leaving too. Suppose you worked out and tell me what you got. Huh? It's the next class. I'm going to start one how much you're getting. I lock the door. Yeah, the machine here. I'll start one how much you're getting next class. All right? So make sure. But that is it. See you tomorrow. Hey, by the way, tomorrow, once I mention it, I want to keep tomorrow class online. But tomorrow's the holiday. Online at 11 o'clock tomorrow. Online tomorrow at 11 a.m. Online
Yes,
for
sir.
everybody tomorrow at 11 a.m.
Yes, sir.
Tomorrow online at 11 a.m. Class tomorrow online at 11 a.m. tomorrow. Online only, because tomorrow's the holiday, so we'll just be online at 11 a.m. tomorrow for everybody. All right?
Awesome.
All right.
Everybody. All right, cool.